Okay, in this section we're going to do basic derivatives. So on the screen you see all of the different symbols that we can use for derivatives. That's how they look. All of them mean the same thing. The first one you have is the constant rule, and a constant of course is a value that doesn't have a variable. So looking at this particular problem here, if I take the derivative of 7, it's going to be 0, okay, because the derivative of any constant is 0. The next rule that you see is the power rule, and you notice I put a big star beside it. That's because it's super important. So a power rule means, of course, you have an exponent. Now we're taking them piece by piece. Eventually they'll have coefficients, and they'll have monomial, binomial, trinomial, they'll have more terms, but right now we're just taking it piece by piece. What the power rule for derivatives tells you to do, looking at the rule above, is it says first to bring that power out in front. So the 4 would go out in front of the x. Okay, once you put the 4 out in front, the next thing that you're going to do is take that power minus 1. So you would say 4 minus 1. So that means that this derivative would be 4x to the third. And that's how it would look. You'll say, oh, the next one's 99. That's tough. So if you take the derivative of x to the 99, what you're going to do is bring your 99 down and then decrease the 99 by 1 in the exponent position. So that would give you 99x to the 98. And that would be your derivative using the power rule. Okay, the next one's a little tricky, but it's most certainly one that you will see. So you'll notice it's an x. Well, an x is understood to be x to the 1. So when we take this derivative, we're going to bring our 1 down, and then I'm going to decrease the 1 by 1. So that would be 1x to the 0. Well, remember your 0 exponent rules from way back when says that anything to the 0 power is 1. So this answer would just be 1. X to the 0 is 1. So this answer would just be 1. The next rule that you have is the constant multiple rule, and that means you have a coefficient in front of an x term. So here's how that rule plays out. So looking at this 5x to the 7, the 5 is just going to stay out front. You're not going to do anything with it. And that's what they do here in the definition at the top of the page. Once you do that, you're going to take the derivative of the x to the 7th term. So to take the derivative of that term, you're going to say that 7, bring down your 7, x to the 7 minus 1. Okay, cleaning that up, we would have 35 out in front, 5 times 7, x to the 6th. And that's how that one would look. Okay, so let's try another one of those. For the second one, I have the 11 out in front, just sitting there all by itself. And then I'm going to take the derivative of this x cubed. So taking the derivative of the x cubed, I would bring the 3 down, and I would decrease the 3 by 1. So cleaning that up, it would be 33 out in front, x to the 2. Okay, looking at the last one, remember this here is 4x to the 1. That's what it's understood to be. When I take the derivative, I'm going to just keep that 4 all by itself. And then I'm going to take the derivative of the x to the 1 piece. So taking that derivative, I would bring the green 1 down, and I would decrease 1 by 1. So cleaning that up, I would get 4x to the 0. Well, remember x to the 0 is just 1, so this would be 4 times 1, which is just 4. Now, sometimes those plain x terms are a little tricky, but here's something that can make it a little bit easier for you. Let me write over here where I have a little bit more room. Earlier, you had a function that was just 1x, and now you have a function in this one that is 4x. So if you have a plain x to the 1, your derivative is just this number in front. So for this one, your derivative would be 1. For this one, your derivative would be 4. So if you have just an x to the 1 term, the coefficient is that term's derivative. Okay, so now you have the sum or difference rule. So if you have this, that means that each of these elements you're going to take the derivative of, one at a time. So taking the derivative of this particular function, we're going to go a little bit faster. We have 6 and 5. So remember, I bring the 6 down, so that gives me 30x to the 5. Now the way that I got that 5 right there is it was 6 minus 1. Okay, let's move to the next one. You bring your power down, so 2 times 3 would give me 6. When I decrease this power by 1, 3 minus 1 gives me a 2 in this position. Moving on along, that's a minus. 11 times 2 is 22. When I decrease my power, 2 minus 1 would give me x to the 1. Moving on along, I have a 5x. Remember, 5 is that derivative. And looking at the last one, that's a constant. The derivative of a constant is just 0. So cleaning this one up, we would have 30x to the 5th plus 6x to the 2nd minus 22x plus 5. And that's how it would look. I'm having a little bit of trouble with the pen, so I'll see if I can clean it up just a little. Now, looking at this last one, I ask you to take this derivative, and for those of you that viewed previous videos that I've posted, this is the derivative problem that I asked you to do with the definition of derivative. So this was a long video using the drawn-out definition. So this one's going to be much easier. So when I get ready to take this derivative, I bring that front 2 down. So 2 times 2 gives me 4. When I decrease the power by 1, 2 minus 2 gives me 1. In front of this is just an x to the 1 term. So remember, an x to the 1 term, all you have to do is take the coefficient. So that's the derivative. Hey, just in case you needed a little bit more help with this one, let me write out all the steps for you one more time. In this first one, you already have a 2 out in front. When you get ready to take the derivative of the second part, you would say that's a 2 bring down, x to the 2 minus 2. So for this term, you'd have a 4, that's x to the 2 minus 1. Let me start that back over. So trying that one more time. You have a 2 out in front. Taking the derivative of the x squared piece right here, we're going to bring a 2 down. And you decrease the 2 by 1 because the power rule says take 1 off of that. So that would be 4x to the 1. When you get ready to do the 20 part, that's negative 20. And of course this would be x to the 1. So taking the derivative of x to the 1, that would be a 1 x to the 1 minus 1. So that would be minus 20 times x to the 0. Okay, well remember x to the 0 is just 1, so this would be 4x minus 20.